Okay, last gas law is Dalton's law of partial pressures. And gas pressure is going to depend on the number of gas particles that are in a given volume and on their average kinetic energy. So kinetic energy is how much they are moving around. So if you increase their kinetic energy, they're going to move around faster. That's going to increase the gas pressure. If you decrease their kinetic energy, it's going to slow those particles down, and the gas pressure is going to go down as well, like we saw with Charles's law. Each particle makes the same contribution to the pressure. So if you know the pressure exerted by each gas in a mixture, you can add those individual pressures to get the total gas pressure. The contribution that each gas in a mixture makes to the total pressure is called the partial pressure. So you have these partial pressures adding up to the total gas pressure in that container. So Dalton's law says that at constant volume and temperature, the total pressure exerted by a mixture of gases is equal to the sum of the partial pressures of the component gases. And this is just one form of Dalton's law, so we're going with the easiest one here. And it's P total, so that's your total pressure, equals P1 plus P2 plus P3 plus however many partial pressures you have. So the sum of your partial pressure is going to equal your total pressure. So if we have a container of air containing oxygen gas, nitrogen gas, carbon dioxide gas, and trace amounts of other gases, what is the partial pressure of the oxygen at 101.3 kilopascal of total pressure if the partial pressures of nitrogen, carbon dioxide, and other gases are 79.1 kPa, 0.0420 kPa, and 0.946 kPa. Okay, so we're going to start by writing our formula. And it is P total equals, we have oxygen, nitrogen, carbon dioxide, and other gases. So partial pressure of your oxygen plus the partial pressure of your nitrogen plus the partial pressure of your carbon dioxide plus the partial pressure of your other gases. And they give us the total. They're asking what is the partial pressure of the oxygen. So since we are looking for the oxygen, that means that we need to get rid of the rest of this. So we can subtract these from both sides. And so this will go away, leaving us with the total pressure, which is 101.3 kPa minus the 79.1 plus the 0.0420 plus the 0.946, and so 101.3 minus 79.1.0420.946. That gives us 21.212. Now remember, when you're adding and subtracting, you have to go by the least number of digits after the decimal. And here we have 1 and 1, so that means we need to report our answer as 21.2 kPa.